Hello everyone, welcome back to my channel, and in this video I'm going to talk about the solution of flight mechanics problems from GATE Aerospace 2014 question paper. And this video is going to be very useful for the students who are preparing for GATE Aerospace 2021, and also equally useful for the students who are in third and fourth year of BTech Aerospace Engineering, and or the students who are in BTech Mechanical also and preparing for GATE Aerospace. So please watch this video if you are preparing for GATE exam, and I'm sure you will get some benefit out of this video. So with this, we'll start the video. Let us move to the questions. So here, as you can see, there are questions starting from question number 6, question number 21, 22, 23, 24, 20, 51, 52, 53, 54, and 55. Okay, so let us start with the solution. So question number 6 says NACA 5-digit airfoil, and we have to find out CL and XM, where CL is the lift coefficient and XM is the maximum camber location. Okay, so if we talk about NACA 5-digit airfoil, and I'll talk about the nomenclature. So let's say, for example, which is given in this numerical NACA 12018. So if I talk about the first digit, when first digit is multiplied with 0.15, so that gives the value of CL. Okay, then second is second digit, which is if multiplied with 5, and in terms of percentage it gives the location of maximum camber, so 0.1 C. So if I look at the options, so you can see option A for CL is equal to 0.15 and XM is equal to 0.1 C is the correct option here, but we can discuss other digits also. So third digit, if we talk about, if it is 0, that means it is a normal airfoil, the conventional one, and if third digit is 1, that means it is a convex airfoil, reflex, it is a reflex airfoil. Okay, then last two digits if are multiplied, uh, they give the last two digits gives the maximum thickness in percentage. So last two digits are 18, that means 18%. So this is the value of maximum thickness of the camber. Okay, so this is the process of nomenclature. So option A was the correct one. Then next question is question number 21. The moment coefficient measured about the center of gravity and about aerodynamic center of a given wing body combination are 0.065. So CMCG for wing body is given as 0.0065, whereas CMAC is minus 0.0235. The aerodynamic center lies 0.06 chord length ahead of center of gravity. That means this is, if this is aerodynamic center, so it is having a distance of 0.06 ahead of CG. That means XCG minus XAC is given as 0.06. Okay, so we have to find out what is the value of CL for wing body combinations. So we know that CM CG for wing body is given by CMAC plus CL XCG by C bar minus XAC by C bar. Okay, so this is the equation for pitching moment of wing body about the center of gravity. So from here, if I put the values, so 0.0065 is equal to minus 0.0235 plus CL into 0.06. Okay, so from here I can easily calculate CL, which is 0.0065 plus 0.0235 divided by 0.06. So 0.065 and 0.02 means about 0.0295, like it is about 0.030, like this. Okay, 0.00030, 0.06. Okay, so that means it is 1 by 2 or zero point 0.5. So CL value is 0 0.5. Then next question is the vertical ground load factor on a stationary aircraft parked in its hangar is. So vertical ground load factor is basically given by the formula. Let's say this is the airplane which is parked in its hangar. So this is the weight of the airplane. This is the reaction of the ground on the airplane, and when the airplane is parked, it is in equilibrium condition, so whatever reaction is there on the body of the airplane from ground will be equal to the weight. So ratio of these two is R by W, and both are equal, so that is why it is equal to 1. So option D is correct. Question number 23. Under what conditions should a glider be operated to ensure minimum sink rate? So we know that sink rate is given by V infinity sine gamma, where this gamma is the gliding angle. So we know that V infinity d by W, or V infinity d by L, or if I write here V infinity CD by CL. Okay, and I know that uh, lift is equal to weight is equal to half rho V infinity square S into CL. So if from this equation I take V infinity as under root of 2W upon rho S into 1 upon CL power 1 by 2. So if I put this value of V infinity into this equation, so that will give me sink rate is equal to 2W upon rho S into CD by CL into CL power 1 by 2, or ultimately that is sink rate is denoted by H naught, so it is directly proportional to CD by CL power 3 by 2. And here we can see for the minimum value of this should be minimum, that is why minimum sink rate is given by this option D, minimum value of CD by CL power 3 by 2. Then question number 24. In most airplane, the Dutch roll mode can be excited by applying. So I step input to the elevators, I step input to the rudder, a sinusoidal input to the aileron, an impulse input to the elevators. So we know that the Dutch roll is something like this. If it is the front view of the airplane, and in normal condition it should follow this path, but in Dutch roll it goes like this. Okay, that means along with rolling there is a yawing movement, and yawing movement can be excited by the rudder. That is why a step input to the rudder is the correct option here, because elevator is directly proportional to the pitching motion, so these two options cannot be there. Okay, and this sinusoidal input to the aileron is also not a correct option, so that is why option B is the correct one here. Then question number 51. For a given airplane with a given wing loading, executing a turn in the vertical plane, under what conditions will the turn radius be minimum and turn radius be minimum and turn rate be maximum? So we know that the turn radius formula is equal to R is equal to V square upon Gn, whereas the turn rate of the airplane is given by Gn by V infinity. Okay, so here they're asking about turn radius be minimum. That means R minimum condition will be met when this should be minimum. Okay, so here what we can do, V infinity upon G, this is L by W. Okay, so L by W means if I take V infinity by G, half rho V square S into CL, and this W is here. So from here what I can say, that turn radius will be minimum for R minimum will be when this will be maximum. Okay, because this is in the denominator and highest value of CL max will give the value of R minimum. So that is why highest possible CL, so that is available in two options, A and D. So B and C are eliminated. Next is omega. So omega can be maximum when load factor is maximum. Okay, so that means omega max is equal to n max. Omega max is directly proportional to n max. So here you can see highest possible value of CL and highest possible value of load factor. So you can see the option D is the correct option as per the given conditions for question number 51. Next is question number 52. Lift off distance for a given aircraft of weight W is SLO. So SLO we know that is directly proportional to 1.44 of W square. If the takeoff weight is reduced by 10%, means new weight is point we can say W minus zero point 0.1 of W, that is 0.9 W. So this is the new weight. That means SLO new is 1.44 of 0.9 W square. And if I take, let's say this is equation number 1, this is equation number 2, if I take the ratio, so SLO by SLO new is equal to 1 by this. That means SLO new is equal to 0.81 of original SLO. That means 81% of the original SLO. That means there is a reduction of 19%. Okay, so 19% reduction. So that is answer is 19%. Okay, so this is the reduction, 19% reduction we can write here. Then question number 53. So question number 53, if we read, which of the following design parameters influence the maximum rate of climb for a jet propelled airplane? Okay, so maximum rate of climb for a jet propelled airplane, for that we have to know what is R by C max. Okay, so R by C max we know that is directly proportional to T by W max, then CD naught, and L by D max. Okay, so these R by C maximum is directly proportional to these three parameters. That is why if we check the answers here, so maximum thrust to weight ratio, zero lift drag coefficient, and maximum lift to drag ratio. So option D is the correct option here. So next is question number 54. So in question number 54, there are four statements we have to consider, and we have to look at the four statements, and um, we have to determine whether these four are correct or incorrect in the context of stick fixed longitudinal balance and stability. So balance means the equilibrium or the controllability, whereas static stability. So let us read the statement. So statement B says CMCG at zero lift must be positive. So let me draw the diagram. As I know that for static stability the slope is always negative, the Cm alpha slope. This is Cm, this is alpha, this is dCm by d alpha. So this is always negative for a static stability. And here the CMCG at zero lift. At zero lift is occurred when alpha is zero. So Cm naught is basically positive. So that is correct. Then DCM delta Cm by Cg, this thing is negative, so this is also correct. CMCG at zero lift must be negative. That means either it can be like this or it can be like this. So if it is like this, then static stability is there, but Cm naught is less than 0. That means if I extend this in this direction, so it will be crossing this, and this value is alpha trim, which is negative value, and that means airplane will be flying in this position at trimmed condition. Okay, that means in this position it is very difficult for a pilot to control the airplane, so that is why this is totally unfavorable condition. So option R is totally wrong. Then slope of CL versus alpha must be negative. So we know that CL versus alpha slope is always positive like that. So this option is also incorrect. So what we will do, we will eliminate the options which are having R and S. So this is having R, so this is incorrect. This is having R and S, this is also incorrect. And here P and Q only, so P and Q both are correct, so this is correct option. Here S is there, so S is incorrect, so this option is also incorrect. So that is why option C is the correct answer here. So this is question number 54. Next is question number 55. So for a light single engine propeller driven airplane in steady level flight sea level is as follows. So V infinity is given, weight is given, CL is given, CD is given, PA is given, rate of climb possible for this aircraft under the given conditions. We know that rate of climb is equal to PA minus PR by W. PA minus PR is basically the excess power. Excess power is what? The difference of power available and power required. And in terms of thrust, if I want to write, it is written as TA V infinity minus TR P infinity by by W. So this we know that PAV is there. PR can be calculated because we know TR, and TR is for steady and level flight is equal to D. Okay, so TR is equal to D. That means D into V infinity is nothing but PR. Okay, so PR can be calculated. I will write it here. D into V infinity, and D is what? Half rho v square s into cd into v infinity. Okay, if I divide it by Cl and multiply with Cl. So what I will get here as this half rho v square into S into Cl is nothing but is equal to weight, because L is equal to W, this plus into this. So this is W into CD divided by Cl here divided by P infinity. So this is PR. Okay, so here in this equation, if I expand CD as per the formula given in the equation, so PR is equal to W by CL, and 0.025 plus 0.04 CL square into V infinity. Okay, so V infinity, that's it. Now I can put the values because I know W is given, CL is given, V infinity is given. So PR is calculated, and PR after calculation is 33520 joules per second. Okay, joules per second. So this is PR. PA is given in the problem, which is 1 lakh. So if I put the value of rate of climb here, so that is 1 lakh minus 33,520 uh, divided by uh, W. W is 13,000. Okay, so if I solve it, I get the value of 5.1138 meter per second. And if I compare this value with the given options here, you can see option B is the correct option. Okay, so guys, this was the solution of flight mechanics problems from gate 2014 for aerospace engineering. And I hope you understand the solutions which I have discussed here. And if you like my solution, then you can share this video with your friends also. And with this, I would like to stop my video. Thank you all of you, and take care. Good night.